Can you guys hear me? Is the audio clear? Just if somebody could type yes or yes, I think that would be great. Okay, thanks, Kaushik. So we'll just wait for a couple of more minutes and then we'll get started. So if somebody is joining this session for the first time, as in if you haven't seen the previous two sessions, you might find a few concepts a bit difficult to follow because I have already explained them in the previous session, so I won't go through them in detail. I'll just quickly go over them. So if you don't understand, it might be worthwhile going to the previous session and just revising them. So I'll start now. The purpose of today's session is that we'll go through some questions. And I had thought of going through difficult questions in this session, but there are difficult questions. These are reasonably difficult questions of the kind you can expect in CAT, but they're not like really out there. So what I have excluded from today's session are a few difficult questions on remainder, etc. Things related to Chinese remainder theorem, Wilson theorem, those kind of stuff I have removed because my sense is it's not very important. What I'll do is I'll take a separate session for those topics later on when we are slightly closer to the exam, because I want students to focus on this stuff first and nail it down. We can do that later on. Even if we don't do it, it would be fine, but we will do one more session. So that stuff you won't find here, but otherwise we'll look at different kinds of questions which I think you should know and you should be able to do, and will hopefully expand your thinking in terms of solving number system related questions, because the kind of question that can be created is vast. So the more you are exposed to, the better you should be equipped with in answering these questions. The way we will go about this, we'll solve these, but then we expect you also to revise them continuously, so that if any trick or anything you see in these questions, you are able to implement when you see a similar question in the exam. So we'll start with the first one. Hi Deepak. So we have a rational number a by b where a and b are co-prime, and it's converted into a decimal number. If both a and b are less than 100, then for how many values of b will a by b always be a terminating decimal? I think you are not able to see the question, so I'll just maybe try and move them a bit so that you can also see it. Not sure if this is working here, but I'll just tell you what the question is. So the question is stating that there are two numbers, a and b, and they are co-prime. And when you write a and b, it is always a terminating decimal. So how many ways can you write a and b? As in, how many values of b can you have, so that such as if a and b are co-prime, the decimal format will always terminate. I'll explain the question, Pritha, so don't worry about it. I'll try and move it. So I've moved it. So a by b has are co-prime, and then in how many values of b will a by b always be a terminating decimal? So for this, what you need to know, and the only thing you need to know, is that the only values in the denominator for which the decimal will terminate irrespective of the numerator. So that's what the question is asking, that whatever be the denominator, whatever be the numerator, the function should terminate, as in the decimal value should not be recurring. And that can only happen if b is a factor of 2 and 5. It should only have 2 and 5 in them. Then whatever be the number in the numerator, it will not terminate. So we have to find how many values of b can it take, and the number of values of b you can count between 1 to 100, which will have 2 and 5 as factors. So how many values of b will take 2 and 5 as factors? So all the powers of 2, 4, 6, 8, 16, 32 and 64. If they are in the denominator, the fraction will always terminate. All the powers of 5, so 5 and 25. Because we are only going till 100, the question mentions that both a and b are less than 100. So 5 and 25 will be there. And then numbers which are product of 2 and 5. So that will be 10, 20, 4 into 5 is 20, 25 into 2 is 50, 8 into 5, 40. And are we missing anything? Less than, 6 won't be there. 6 won't be there. So total we get is 25 into 2, 50, 8 into 5, 40, 16 into 5, 80. So in total we will get 6, 2, 8, 9, 10, 11, 12, 13. So there are 13 values of b for which whatever value you keep in a, there are 13 values of b for which whatever value in a you have, the function will terminate, and that would be the answer. So one, you need to remember from this question, the takeaway is that you should remember that the function terminates for any numerator if the denominator is a factor of 2 and 5. The other thing which you need to notice is that the question is not very easily worded. If the wording would have been simple, you would have very easily solved this question, but it's written like a rational number a, b. You do not have to do anything with a, but still there is a lot of detail given around a. So that requires a bit of confidence in the exam. When you are confident about the topic, you will read through the question and be able to remove the non-useful part and only focus on the useful part. So when you are practicing, you should keep an eye out for those things, and also develop that confidence and courage that in the exam you don't get scared by looking at a lot of terms in the question. And there are many such questions in this, at least there are a few, and I'll keep pointing that out whenever we go through. So this is there. Some people here are more seasoned than others, so they would have followed this very easily. If you were not able to follow it, again, you need a bit of practice, revise the previous sessions, again, revise these questions also later on when the session finishes, and you should get comfortable. Let's look at this question. We have to find how many perfect squares are the divisors of the product. So we have been given a number 1 factorial into 2 factorial into 3 factorial till 8 factorial, and how many divisors, how many factors basically would be perfect square. And we have seen somewhat similar questions in the previous session. There is a slightly evolved one. I think I didn't do this one, so we'll just go through this one also. First, you need to find the prime factors. I've already written them here to fasten the process, but I'll just tell you how you need to do it. So what would be the powers of 2 in this product? So we have 1 factorial to 8 factorial. Powers of 2 will be 2 factorial will have 1 power of 2. 4 factorial will have 2 factorial and as in 2 into 4. So it will have 2 to the power 3. 6 will have 1 more 2, so 2 to the power 4. And then 8 will have 3 more 2s because 8 has 3 powers of 2s. So 2 to the power of 7. Just a minute, did I miss something? Because I have 2 to the power 23 here. 2, 4, 6 and 8. So 2 factorial should be 2. 4 factorial will be 2 to the power 3. 6 factorial will be 6 into 4 into 2, which will be 2 to the power 4. And 8 factorial will be 2 to the power 3 into 2 to the power 4. So it will be 2. Actually, then I might have made a mistake earlier. So this would be 4, 3, 7, 7, 14, 2 to the power 15. Oh, sorry, yeah. Sorry. My bad. Completely sorry. It should not only be the even numbers. All the numbers will have 2 to the power 4. So, and then same way, into 3 factorial will have 1, 2, 5 factorial will have 3 twos, and 7 factorial will have same as 6 factorial, which is 4 twos. And you add them, you get 2 to the power 23. And same way, you have to check for power of 3. And power of 3, in 3 factorial there is 1, 4 factorial there is 1, 5 factorial another 1, 6 factorial now we get 2, and 7 factorial 2, and 8 factorial 2. So we get 3 to the power 9. And then you can check for 5 and 7 and you'll reach this number, that which we have provided here, 2 to the power 23 into 3 to the power 9 into 5 to the power 4 into 7 to the power 2. Now we need to calculate how many of them are perfect squares. And for that, you can only take even powers. You cannot take odd powers. How many ways can we take even powers in? For 2 to the power 23, we can take 2 to the power 0, or 2 to the power 2, or 2 to the power 4. I should not add plus, but these are the options that you have. 2 to the power 6, 2 to the power 22. So you have 12 options here. And same way for 3 to the power 9, I have 0, square, 4, 6, 8. So I have 5 options here. And 5 to the power 4, I can again take 3 options there. And for 7, I'll have 1. And I can choose any of these. So out of the 12 options, I can choose any one. Out of these 5, I can choose any one. Out of the 3, for 5, I can choose any one. And for 7, I can choose anyone. For 7, I'll have 2 options actually. 7 power 0. And so the total number of options become 12 into 5 into 3 into 2. And then here perfect squares 1 will be included. Sometimes they might ask a question. They might ask a question where 1 is not included. Then you'll have to subtract 1. So we have so there will be total 360 options. Question. So will 5 factorial and 10 factorial. Yeah, so Deepak, I got that. 7 was a typo, so there is a bit of lag, but I have corrected that. So overall, you'll have 360 options over here. Again, the way we chose these 12 into 5 into 3 into 2, if you have done a bit of permutation and combination, it should be easier for you to follow. So if you are finding that part a bit difficult, you can wait till we do permutation and combinations, but it's not very difficult to think through, even if you haven't. So we'll solve this question and then we'll just pause for a bit so that if you have some comments. Yes, Pritha, I got that I had made a mistake. Find the smallest positive integer for which is a perfect square. So we have been given an expression, and now we need to find the integer for which this number will be a perfect square. How do we solve this? So one thing which is easily visible from the question is that you can split it into a minus b and a plus b. So let's try that. Let's see if that works. So 2 square minus 1 will be split into 2 minus 1 and 2 plus 1. And same way 3 square minus 1 will be split into 3 minus 1, 3 plus 1, and so on. Now what you can notice is that this term and this term are the same. 4 minus 1 and 2 plus 1 is the same. Same way 3 plus 1 and 5 minus 1 is the same, right? So after skipping one term, they find their pairs. So they will form their square, right? So the product, overall product, will have 3 square, will have 4 square. What it would not have is the first and the second term on this side, and the same way the two final terms on the last on the final side. So on the other side you will have n minus 1, n plus 1, and you wouldn't have an n, and the term before that would have been n minus 2 and n. And this number would have found its pair from something behind, and this number would have found its pair, but these two would not have had a pair. So all the other numbers are perfect square except for 3 minus 1, 2 from here. We can ignore the first one, which is 1, 2, n into n plus 1. And then remaining stuff is anyway a perfect square. So that we don't need to worry about. So what we need, and the question is asking, what is the smallest integer for which this number is a perfect square? So what is the smallest value of n for which 2n, n plus 1 will be a perfect square? So it needs to have 2 in here, right? But if we put 2, 2 plus 1 will not be a perfect square. So, and when you do a bit of thinking, you'll reach that if n is equal to 8, then this number becomes a perfect square, because 8 into 2, 16 is a perfect square, and 8 plus 1, 9, which is 3 square, is also a perfect square. So the smallest number is n is equal to 8. I'll take a breath here. If somebody is not following, somebody has a doubt, right now you can comment, and I'll take that. I'll just revise this one again very quickly, just so that if somebody is finding it difficult, they can understand. The question asked, it had given an expression, it wanted us to give us what value of n this number would be a perfect square. What did we do? We took the number, and then it was very easily visible that the number can be factorized into a minus b and a plus b. So we started with that. You have to start somewhere. Most of the time you would see a question, you wouldn't know exactly how to solve it. So you have to start using some basic techniques that you have learned. So we tried that. We split them into their factors, and then we noticed that a lot of numbers were already forming their pairs. So they were already forming their squares. Only a few numbers were left, which was like 2 minus 1 and 3 minus 1, the first two numbers over here and the last two numbers on the other end. And then we combined them to form 2n, n plus 1. If this number were a perfect square, the other parts of this number were already perfect square. How do we find how do we make this number a perfect square? So by hit and trial, we realized that n is equal to 8 is the number for which this number will be a perfect square. So n will be equal to 8. Yeah, so you can use options in a lot of these questions. I'm not focusing a lot on that stuff because you can anyway do that on your own or as a last resort, and you should spend some time doing that. But recently, given that they have introduced typing in options, plus they can always put in options which are not very easy to substitute and check. I mean, the question can be drafted in such manner. So I'm not a great fan of using options while learning or while teaching. But yes, in mocks, etc., you should practice that skill also, that if you can't think of a way, just, or even if you can think of a way, is there a way just by looking at the options, you can solve the question. But while practicing, we should focus a bit more on knowing how to solve it, because there is always a way the question can be asked or the options can be framed that you can't use them very easily. So, and given that they are asking for typing in the answer, my feeling is that they have noticed this, and that's why they are going towards that. So they might be extra careful in not giving questions where options can be just be substituted and you can get answers. So better go this way, but it is an important skill to have and to practice, that wherever you can use your options and solve them, but try them in the mocks because that's the place where you can see how good you are with that. So now here the question is based on options. So I gave such a long speech on not using options, but here the question himself is based on options. So there are 4 options, and the question is asking which of these natural numbers can be expressed as the sum of squares of 6 odd integers. So using I hate Arun Sharma book, Deepak. I like the way it is explained. It is simple. It doesn't complicate things a lot. But I do not like the fact that every difficult question solution is using options solve this. So and that's one reason why I hate that book. So in this question, which of the following natural numbers can be expressed as sum of squares of six odd integers? Even just as we're discussing, even just by looking at options, you can eliminate 96 and 98 because sum of squares of odd integers, oh, sorry, 97 and 99, because sum of squares of six odd integers, all numbers will be odd, and sum of six odd numbers will be an even number. So if in exam you couldn't think of anything, also you should take a guess on 96 or 90, 98, because one of those two will be the answer. There is a 50% chance that you will get it right. So in the exam you can. But now that we have time, we should try just see how to solve this, because the idea here is that you can, when you see how you can solve this question, that would help you solve 10 other questions out there also. So any odd number can be written as, say, 2k plus 1. A square of an odd number will be 4k square plus 1 plus 4k, right? So this is 4k square plus k plus 1, or 4 into k plus 1 plus 1. Or it can also be written as actually 8p plus 1, right? Because k be odd or even, one of these numbers will be even. So you can take that factor also out, and hence the number becomes 8p plus 1. So a square of an odd number would be of the format 8p plus 1, where p can be any value. And now we are adding up six odd integers, odd squares. So six numbers of this form. So it can be written as 8 p1 plus p2 or whatever plus 6, right? We have added six odd squares. And from here onwards, you can check 96 is divisible by 4 and 2000 by 8. So this is of the form 8p plus 4, while 98 is of the form 8p plus 6. So the only answer that is possible is 8p plus 6. So which of the following natural numbers can be expressed? 98 can be expressed. Now, here I need to give one more warning. When we do these questions, they seem very simple. The reason they seem very simple is because I point you just in the right direction. When you yourself sit with this question without the solution, then they're not as simple, because then you see all the 5 different ways you can solve it and all the wrong paths and all the wrong turns. It's just like when you go to a friend's place and he's driving versus when you are going on your own. It's much easier when the person beside you is driving, because then you only see the right paths. But when you are going on your own, you start seeing that there are 5 different ways and I don't know which one to take and which one to go. So it is important that you revise them later also, even if they seemed easy to you right now. When you do it without the solution, it might not seem as straightforward. So practicing is a bit important, and I'll keep repeating that in every session. Let's look at this one. So x is a number. It's formed by the first 100 digits of the number n, which is by writing 100 natural numbers one after the other. So we just keep writing the natural numbers, and wherever 100 digits end, that's where the number stops. We want to find the remainder when x is divided by 16. So first we need to find the number. So if it is, we are writing 1, 2, 3, 4, so on. First 9 digits will be 1 to 9. First 9 digits will be 1 to 9. And then now we have 91 digits left, which means we can take 45 2-digit number, which is 10 to 54, right? This will be 45. And then we need one more digit. So from 55, we will have 5. So the number will be of the form 1, 2, 3, till 9, then 10, 11 till 53, 54, 5. So this is the total number. And now we are dividing this number by 16. And we need to find the remainder when we divide this number by 16. So I think we mentioned this in the last session also. I'll repeat that. When you divide by 8, you only look at the last three numbers. And if these three are divisible by 8, the number is considered divisible by 8. And that is done because you can split this any number into, say, if it's A, B, C, X, Y, Z, you can write this number as A, B, C, 0, 0, 0 plus X, Y, Z. And since 8 divides 1000, this number will be divisible by 1000. So you only need to check the last three. Same way, 16 divides 2000. So if you can write a number in a format A into 2000 plus something, you only need to check for that number, and that remainder that you get from there would be the remainder when you divide by 16. So here, if you have this number, we know that 52,000 would be divisible by 16. So we can split this the entire number into whatever it is still here. Whatever this part is, let's call it A. We can write it as equal to A 2000 plus 1545 by 16. And this part is divisible by 16. So the only thing you need to see is whether this part is divisible by 16. And that you can very easily check. But for that, you don't need a lot of science. So yes, but for that you can go till 10,000. But otherwise also, the way I have explained that concept is much useful. For example, here also you'd have to do it till 53,545. Here you can get by doing 1545. I am responding to Shahil's comment where he mentioned that for any 2 to the power we just need to take the last as many digits. But understanding the concept behind that might be much more helpful. Why you take the last few digits, and that's the same thing because 2 square divides 100, 2 cube divides 1000. And 2 to the power 4 will divide 10,000. So you can take the last 4 digits or last 3 digits and do it. But 2 to the power 4 divides 2000 also. So you can split it just at the 2000 level. So here I have just taken 2000 away and I am left with 1545. So, and this might be useful in other places also where you have different numbers. And we'll do some questions later on if we when we do a remainder class. But here also, or if you want, you can even take all 5 digits, then you'll have to do it for 53,545 and find the remainder. But I find this way it's much more convenient. So, and then you can divide and check what will be the remainder when 16 divides 1545. So this again, we have 2 to the power 36 minus 1 given as a number. So this question, the one that we are doing right now, I would consider it as a relatively simple question. When this kind of a question comes in the exam, you should be able to do it because it is very easily pointing in the direction in which you have to go. There is a number here. You have to find the value of A. If you have done similar questions before, you know that you cannot like find A by multiplying or dividing or anything. It has to be based on divisibility. For some number, we should know that this number is divisible by a certain number, and then you can check for test. 9 and 3 work very well, or 11 works very well. If you know that this number should be divisible by 11, then you can put the test of divisibility and try and get A. So in this case, if you just try and factorize this also, you'll see this is 2 to the power 18 minus 1, this is 2 to the power 18 plus 1, and then 18 minus 1 you can further factorize into 2 to the power 9 minus 1 and 2 to the power 9 plus 1. And at this stage also you can notice that this expression can be written as a cube plus b cube, which is 2 cube plus 1 cube, 2 cube plus 1 cube, and hence you will have 2 to the power 3 plus 1 as a factor, right? So 9 will be a factor for this number. You can even further split and get to that, but from here we get that 2 to the power 3 plus 1 or 9 will be a factor. Hence the sum of digits of this number should be divisible by 9. So what will be the sum of digits? 14 plus a plus, I'm adding 2 at a time, 10 plus 11 plus 13 plus 8, and that is 24, 35, 45, 48, 8, 56 plus a. So this is 56 plus a, and it has to be divisible by a, so a will be equal to 7 to get to 63. There can be different questions like that. The questions can be made more difficult, made more easier, depending on how difficult it is to find the factor, and there might be more complexities also, but at least like you have been exposed to this question, so when you see a similar question you should be thinking in terms of divisibility test and those kind of things. And mostly my sense is if they ask a question, they'll ask similar questions, as in they'll ask questions based on more fundamental thing. Divisibility test is something which everybody knows. Can they apply it is the question that CAT will pose to you. The Chinese remainder theorem is not something which everybody knows, so they're not going to test on something which a few people might have learned in a coaching institute, because it goes against the ethos. They're looking for people with good aptitude, not with very specific knowledge on a certain topic. So so that's the another question on remainder. What is the remainder when this number is divided by 110? Now it is possible to get confused. I have just put in this so that you notice a certain trick, or certain, not a trick, but in certain thing about numbers, and it might be useful. 26 plus 27 plus 28 plus 29 is equal to 110. So 26 plus 27 plus 28 plus 29 equal to 110, and a to the power n plus b to the power n plus c to the power n plus d to the power n for odd n will be divisible by a plus b plus c plus d. So if n is odd, you'll always have a factor which is a plus b plus c plus d. So in this question, it's about observation. It's about knowing this and then observing that the sum of these four is 110, and then since it's odd, this will have a factor 110. So this is true for all odd numbers. So now you should be able to keep that in mind. If you keep that in mind, you should be able to solve different questions. So in this case, the remainder will be 0 because a plus b plus c plus d is a factor. You can think over it, try and remember it. One more thing which is worth remembering. Find the last two digits of 32 to the power 222. 32 is 2 to the power 5, right? 2 to the power 5 to the power 222, which is equal to, if we take one more, 2 to the power 10 to the power 111. And 2 to the power 10 can be written as 1024 to the power 111. Now, there is a result. Just notice this. If you find it difficult to remember, it's fine, but I think it's not very difficult to remember. So the powers of 24, you remember we did cyclicity last time, that powers sometimes the unit digit repeats itself after certain powers. Last two digits can also repeat after certain powers. So 24 to the power 1 is 24. 24 to the power 2 will have 76 in the last two digits, 576. 24 to the power 3 again gets 24 as the last two digits. Okay, so powers of 24 only have last two digits is either 24 or 76, because only the last two digits determine what would be the last two digits. So when you multiply 24 by 24, you get 76 in the last two digits, and then when you multiply 76 by 24, you get 24 in the last two digits, whatever be the number over here. So if I had to ask what will be 5024 into 1076, and what will be the last two digits, it would be 24. And same way, if I had to do like 1076 into 50 whatever, uh, 1024 into 576, again, since it's 76 into 24, it will be 24. And if it were 24 into 24, it would have been 76. So as a result, it specifically it does not very useful, doesn't look very useful, but because 2 to the power 10 comes to 1024, the application actually increases a lot more than you would think otherwise, because 2 to the power 10 is 1024, and now here we know that it has an odd power over here. So for odd powers, we know that the final two digits will be 24. So the last two digits here will be 24. Deepak, I'm reading your comment right now. I didn't read it earlier. So the divisibility one I am ignoring right now. I'll respond to it later, because I'll have to read through it and think through what you are trying to say. Do ABC are in AP, then the other one also I'll respond later, because I'll have to think through what you are saying, because ABC are in AP. I'll have to think through it. I don't know of a standard result. Uh, and if I don't know of a standard result, it's probably not as standard, but there might be a result like that over there. I'll look at it and respond later. Because as you can see on the right side, we have a lot to cover. We have covered a lot actually. It's not that bad. In 30-35 minutes, we have covered a reasonable amount. So if I'm going too fast, also please mention. I can slow down things a bit. We have time, and it's not like cat is tomorrow or something. We have a lot of time to go through all this. Sahil, you are asking a separate question, but yes, 2 to the power 5 raised to the power 111 will be equal to 2 to the power 555. In our case, it was 2 to the power 5 raised to the power 222. It wasn't 111. So that's why we were able to take 2 inside and create 1024. Now we have to, the question is, so this is again a continuation of the previous one. I just wanted to show how that becomes useful. Again, find the last two digits of 1 by 5 to the power 903. Now you can write 1 by 5 as 0.2 and 0.2 to the power 903. The last two digits here mean that since this is a non-terminating decimal, whatever will be the last two digits. So for our purposes, we can ignore the decimal point because that doesn't matter. And you need to find the last two digits of 2 to the power 903. Now 2 to the power 903 can be written as 2 to the power 3 into 2 to the power 900. And now we know for 2 to the power 10 we know. So this is 2 to the power 3 into 2 to the power 10 raised to the power 90. 2 to the power 10 again 24. This will have 24 in the last two places. Raised to an even power. So that will mean the last two digits for this number will be 76. This is 08. And the last two digits of the product would be formed by just the product of these two and these two. So you can just calculate 76 into 08, and whatever you get will be the last two digits of this number. So that way, that result keeps coming in here and there. Whenever you see large powers of 2, you have been asked last two digits, you might think about it in terms of 1024 and raised powers and so on. Okay. I'll again take a pause here just in case somebody has questions, doubts, etc. All these things, it's good to know, but it's important to make it your own. As in, you should be able to teach this stuff. If you have reached that level of expertise, then it's worthwhile. Then your practice is good enough, because it's always easy to hear and think that you know, but in the exam it won't be the same question, it will be a different question, and so to be able to apply that knowledge, you need to be extremely comfortable with all this. Uh, Sahil is commenting that last two digits repeat after every 20 parts. Uh, Maybe I don't know about that. So you might be on to something there. I do not know, so I won't be able to comment. But if it does repeat after every 20 parts, then yes, you can just use the 2 to the power 3, because then 2 to the power 3 would be repeating after every 20 parts. Let's look at this one. If n is equal to 1 factorial minus 2 factorial plus 3 factorial minus 4, then what is the unit digit of n to the power n? So again, on the face of it, the question looks a bit more complicated. What will be the unit digit of n to the power n? But when you simplify, it becomes much more easier. So as you know, after so 5 factorial is 120, and we did some of this in the last session also. 6 factorial is 720. So any number greater than 5 factorial will have 0 in the final place. So the numbers which will be determining the unit digit are the first four: 1 factorial minus 2 factorial plus 3 factorial minus 4 factorial. So let's look at them. 1 is 1, 2 factorial is 2, 3 factorial is 6, and 4 factorial is minus 24, right? And this will give us minus 19, and then you will be subtracting 19 from bigger number, so the unit place you would get is 1, right? So our unit place number would be 1. So whatever be this number, it will have 1 in the unit place, and it is raised to a number which can be anything with 1 in its unit place. The unit place doesn't matter. So we know that if a number has 1 in the unit place, whatever power you raise it to, it will still have 1 as the unit place number. So from that, we can say that the unit digit of the number is n to the power n. Unit digit is 1. So the only thing, so when the question comes, how would you think about it? What you can do is you can try simplifying this expression. You'll notice that this will have 1 in the unit place. You should remember that the unit digit only gets determined by whatever is in the unit place and the powers it's raised to. So you have an incentive to find the unit digit number, and that's easy to find. So you find 1 as the unit digit number, and once you find 1, you know that whatever be the number I raise it to, I'll still have 1 as the answer. So this is how you can think through when the question comes in the exam. So some people, if you are finding it onerous, that's a different thing, because these questions are not very connected. They're all separate questions, and that's how number system a lot of questions are. We have done questions related to one particular topic in the previous 2 sessions. So here the idea is to just go through questions quickly. So if some people are finding it difficult to follow, again, revising previous material might be helpful before coming to this one. The question says n is equal to 99918 times. How many 9s are there in n square? So how we can do it is, so it has 18 9s. We can write it as 10 to the power 18 minus 1, right? So n square will be equal to 10 to the power 36 plus 1 minus 2 into 10 to the power 18. And now we need to find how many 9s would there be, and that's not very difficult actually. So 10 to the power 36 is 36 zeros. we'll add 1, so we'll get 1 at the end. But then we are subtracting 2 into 10 to the power 8. So at so let's just do it actually, that will make it clear. So we have 36 zeros here, and then we have 2 with 18 zeros here, right? So 18 zeros here. The 1 can be ignored, it won't matter unless we are counting number of zeros. And we have 36 here. So when you subtract, the last 17 would be 0 or 1, last 18. Then the 19th number, 10 minus 2 will be 8. So we'll have 18, 0 or 1. And then 19th will be 8. And then after that, you will have all these as 9. Right. So 18 this, 19th will be this. Will it lose 1 digit because now it's coming down? So 36, the total there will be 35. So 35 minus 19, you should have 16 nines in there. So the number of nines will be 16. Again, how will we think about it? So there is a number with 18 nines. We are squaring it. When we square it, why do we write it like the way we have written it over here? The way we have written it over here is because we know that writing it this way helps us square it easily. So we write the square form much more easily. So we get 10 to the power 36, 2 into 10 to the power 8. And from here, it's easier to subtract and count how many nines are there. That's what we have done. This again is I think is a fairly simple question. I think you should also be able to do it. So let me just check how many people are paying attention. So I'll just wait for 60 seconds. Let's see if some of you can post the answer and how fast can you do it. Yep. 2 is the answer. I just realized I can't wait for a long time because we keep these videos also for others to revise. And in live, it's not that bad to pause for some time. But when people look at it on the recorded version, they get bored if there are like long pauses in there. So 2 is the answer and it's relatively easy. So 24 to the power t equal to 25. But then according to the way it has been given, 5 to the power a is 6 and 6 to the power b is 7. 23 to the power s will be 24. So we can write 24 as 23 to the power s. And then same with 22 can be written as 25 to the power, 22 to the power r and so on. So A, B, C, D, R, S, T will reach 5 eventually, is equal to 5 square. And hence the product is equal to 2. So this will also be considered a reasonably easy question, not very difficult one. Because the direction there is only one direction in which you can progress, and when you progress in that direction, you get the answer. So it won't be considered a very tough one from that regards. Let's look at this one. X is a 6-digit number beginning with 1. If the digit 1 is removed from the leftmost place to rightmost place, the number obtained is 3 times of S. So there are questions like this. Solving all of them is, there are similar methods. So let's look at one. So S is a 6-digit number. It begins with 1. So let's assume the number is 1, A, B, C, D, E. Now what we do is, if we remove 1 from leftmost place to the rightmost place, the number obtained is 3 times of S. So if we multiply this number by 3, what we get is 1 removed to that side. So we get this. And there are various questions like that. Sometimes it may be sum, sometimes it may be multiplication, and so on. So solving them, the method is the same. Let's see. You need 1 in the units place. So 3 into E will get 1 in the units place, right? What should E be? E has to be equal to 7. So now we know that E is 7. So we replace 7 here. We know E is equal to 7. So we replace 7 here. Now what happens? 7 into 3, 21. 1, 2 gets carried over. 3 into D plus 2 is equal to 7. So now we get 3D plus 2 gives you 7 in the units place. So 3 into D gives 5 in the units place. So what should D be? DB will be equal to 5. So now we can again replace D. So D is 5. And you continue in the same manner. Now you need 5 over here. You'll do 3 into 5, 15 plus 2, 17, 7, 1 remaining. 3C plus 1 will give 5 as the remainder. So 3C will give 4 as the remainder. So C will be equal to 8. So C will be equal to 8, and this number is 8. And then you can continue in the same manner. You will get the result. For example, now 3 into 8, 8 plus 24 plus 1, 5, 2 carried over. 3B plus 2 is 8. So just don't forget the carryover terms and you will get the right answer. 3B plus 2 is 8. So 3B is 6. So B will be equal to 2 and we won't have a carryover due to B. So this becomes 2. This also becomes 2. And now 3 into A is 2. So A is 4 and you get the answer. So you get the answer 142857. This one I just kept in as a reminder of that so that you haven't forgotten the things. I'll very quickly do it. You guys can do it later on. The only thing to notice here is if you don't notice that, you would find it very difficult to solve. You won't be able to solve it. If you notice it, it's very straightforward to solve. X is told to be between, it's a 2-digit number. So it will be 10 and 99. It will be between 10 and 99, and for all those numbers this number will be equal to 0, right? So when this number will be equal to 0, actually I think the actual question was with 1 inside, so it was like this. But even with this, when this number will be equal to 0, so 1 plus this will always be equal to 1. So this number for all 2-digit numbers is 1, and hence for x by 9 will be 1 only for x element of 9, 10, so on till 17. So you need 2-digit numbers, so 10 to 17 or 8 values will be the correct answer. So it's just straightforward. X, Y, Z are natural numbers, so that x less than y less than z, and 1 by x plus 1 by, how many values can y take? So what we have been given is 1 by y plus 1 by z equal to 1, and x, y, z are natural numbers. So how many values can y take? Now x cannot be equal to 1. X cannot be equal to 1 because then the number becomes greater than 1. So can x be equal to 2? Maybe, but so when you find the lowest number, let's say x is equal to 3, then 1 by 3 plus 1 by 4 plus 1 by 5 is the maximum this number will be able to achieve, because y has to be greater than x and z has to be greater than y. So the maximum this number can achieve is 1 by 3 plus 1 by 4 plus 1 by 5 for x is equal to 3. And this will be less than 1. This is not equal to 1. So x has to be equal to 2. It cannot be equal to 1, it cannot be equal to 3 or any number further. It has to be equal to 2. So now our equation gets reduced to 1 by 2 plus 1 by y plus 1 by z, or 1 by y plus 1 by z is equal to 1 by 2. Again, y cannot be equal to 1 because then this number, y cannot be equal to 2 because again the sum will become greater than 1 by 2. So the greatest and then for 1 by 4, if its y is not equal to 3, then for 1 by 4 plus 1 by 5, which is the maximum you can get if y is equal to 4, will be less than 1 by 2. So y has to be equal to 3. And this is the only value which y can take. And for that, you can calculate the value of z. I think it comes to 1 by 6. So how many values can y take? Y can take only one value, which is y is equal to 3. Right? So basically here we are playing on the fact that we have been provided y has to be greater than x, z has to be greater than y. They all have to be natural numbers. And that puts a lot of constraints on this one. We are using those constraints to say that since this is an equation, they have to be equal, and as soon as x crosses a certain value, these guys also cross at that value, and so all the entire sum becomes lower, and hence using that you can identify which values will satisfy the equation. So you start with the smallest one because that will put a constraint on the other ones also. So you just check whether x is equal to 1, satisfy, no, it won't satisfy. X equal to 2 might, so you just check for the next one, and for the next ones you know that what the maximum will be. In a different version of the question, if the question is worded differently, you might be finding the minimum of the even in this case, if the numerator were like x plus y plus z, then if you had put a constraint x equal to 3, then y equal to 4 or z equal to 5, and this will give you the minimum that this number has to be. So you might have to think around those lines also. So ek do baar just go through this, revise this if you find this, see such things for the first time, so that when a different version of the question comes, you are well equipped to make the adaptation necessary. Again, same question won't come, but a similar question might definitely come. So we can again go through it if you need, but I think once you see the solution, it's reasonably easy to understand. This is a kind of question where it's more difficult to understand if you have never seen the solution. Once you have seen it, you know I'll be able to do it. So and such questions are common in CAT. Like most people, when they come out of the exam and then they see the paper solution, they know that they could have done a lot more than what they did. We want to solve this one. It's again a remainder related question. Let me see how much we have left. This one you can, I think I'm not a great fan of doing a lot of remainder question basically. So that's why I try and avoid doing much, because I don't want you to be wasting a lot of time in doing this stuff. The chances of them coming are lower. If they come also, it would be reasonably straightforward. So we are dividing by 17. We need to find the remainder. What would the remainder be? You can write it as when you divide by 17, 38. So 38 is 34 plus 4. So using what we had studied last time, you can write it as 4 to the power 16 factorial to the power 17. Not like this, but as in the remainder would be the same. So what I've done is I've taken out the 34 of this. And now, 16 factorial would be an even number. So we'll multiply it by, we will take the square, and then it comes to 16 to the power 16 factorial by 2 to the power 1777, right, by 17. 16 can be written as 17 minus 1, right? And to some power, all this is an even number. We just need to remember that. This is an even number by 17. And so some of you might be able to do this right now. Like this is just the remainder theorem, right? 16 aa gaya, to 17 by 16, this is minus 1 to the power even number. And so the remainder will be 1. Or you can just imagine just the binomial expansion also. All the expansion numbers will have 17 as a factor. So 17 will be a factor for all of them except for the last one, which will be plus 1, and that won't have a factor. So 1 would be the remainder. Uh, I think I'll stop after this one. We have been on for 1 hour, so this is the final question. The rest ones I'll just show the screen so that you know the question. If you want, you can practice on your own. The number of zeros in the product. So here we have 1, 2 to the power 2, 3 to the power 3, and so on. And we have to find how many zeros there would be. And as we have seen in other such questions, it's the power of 5 which determines how many zeros you will get. So basically, we need to find how many powers of 5 there will be. So, sorry, just a second. So this will be 5 to the power 5 into 10 to the power 10 into 15 to the power 15 to 100 to the power 100, right? And now you can count the number of 5 basically. So it's the same thing. So first will be 5. There are 5 plus 10 plus 15. So this is 1 5. This is another. This is another, and so on. 25, 50, and 75 we'll consider separately. So this is ones for all the 5 powers, because 5 to the power 5 will have 5 5, 10 to the power 10 will have 10 5s because 5 to the power 10, 15 to the power 15 will have 15, and so on. Plus, since 25 itself has 2 5s in it, so we'll add 25 more for 25, and same way for 50 we'll add 50 more, and for 75 we'll add 75 more, and for 100 we'll add 100 more. And this is the total number of 5s, and number of 2s will definitely be there. So we just need to add this, and this will give us the total number of zeros. So I'll stop here. I just wanted to say what we haven't covered. So number system, I think we have covered most of the basic stuff. This kind of stuff we haven't covered. I'll do a separate remainder related question session. It will be much late in the day and only for people who are interested at that point of time. It won't be anytime soon. Maybe I'm thinking sometime July, August or something like that. Base changes, I haven't included it in this set. You won't find questions also on the portal. Again, my sense is it's not that critical, but we will do a session. I think we might do it next or the week after itself. So that you get at least comfortable with it. We'll do some of the basics of base change related questions. But this is still not covered. But otherwise, I think we have covered most of the things. So you can attempt questions everywhere. Bring them to me. If you see this kind of things, Chinese remainder theorem, Wilson theorem, and you don't understand, don't worry a lot about it. I would suggest even like just figure it out. Many a times I think now I am getting students to prepare for mock than for the real CAT. Like I know this won't come in CAT, but it might come in mock, so I should rather teach them, because otherwise they'll say I wasn't taught this and so on. But I don't, I'm not very fond of that stuff. So if you want to ignore it, feel free to ignore it. If you are very keen on studying, just Google and read that part. But otherwise, practice these questions, practice the questions we did in the previous sessions, practice the questions that are there on the portal. And then if you want to practice certain books or certain other material, feel free to do that. If you have questions, feel free to come back and ask. We'll be responding. These are a few other questions which I thought I'll do if I have time. I don't today, but if you want to, you can take a crack at it in your own time. Sorry, this I think was supposed to be here, but this is the material. So we have covered most of this. HCF LCM I haven't covered. You can study it yourself. The videos are there. Factorization, remainder, all this you can attempt. In the advanced section, there are a few questions which are based on what I mentioned earlier, Wilson theorem and CRT, etc. On the solution, I have written on the top that if you don't, you can feel free to ignore. So you will know which questions are those. So don't worry about that. This was another one which I had thought I'll do. And this was the third one. So I'll stop here. Thanks a lot for attending. Any feedback is welcome, privately or publicly. And we'll see what sessions we do. For the pro batch, we are doing a parajumble session next weekend. Please attempt the required material for that, and we'll do that. And on the quant side, I think we might take a bit of a break. We might focus on DI and LR for a bit of time, and then we'll come back with we'll focus on speed, time, ratio, proportion, and those kind of things within a couple of weeks. Meanwhile, please complete the required material. Thank you very much for tuning in. Have a nice Monday.